Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And I'm Ryan. For math homework help, call in Bakersfield 636-4357, and everywhere else, call 1-866-636-6284. An email for Do the Math is dothemath@kern.org. We're online at dothemath.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Ryan, where do you go to school and what grade are you in?
I go to Buena Vista Elementary, and I'm in 6th grade.
All right, so you're a bulldog.
Yep.
Have you been a bulldog for a long time?
Since kindergarten.
Since kindergarten, okay. So you've been there your entire schooling, kindergarten through 6th grade, you've been at Buena Vista. Do you know where you're going to school next year?
Yeah.
Where will that be? Can you tell us?
Warren.
Okay. And is there anything that you're looking forward to when you go to junior high school?
The different classes and things that you might be able to do.
Okay, so you're looking forward to go to different classes and you get an opportunity to do electives,
Yeah.
correct? And have you thought about that at all yet?
Yeah, I'm thinking about either doing music or an extra like reading or math class.
Okay. Are you in music now?
Yes.
So do you play an instrument?
Yeah.
What do you play?
I play an alto saxophone.
All right. And have you been doing that for a while or is that something pretty new?
That's since like 5th grade.
Okay, yeah, I was going to say most kids start that around 5th grade or something like that. Well, good. So you enjoy that?
Yeah.
Good. Well, we're going to have a lot of different math to do today, but first I need you to help me with our social media problem of the day. Are you ready?
Yeah.
All right, let's take a look at it together. It's up on the board. So it says, what is the outlier? And we have a bunch of numbers up there. So when you see that, what comes to your mind, first of all? What do you think they're talking about with what is the outlier?
I think they're talking about which one stands out.
Okay, so taking a look at that, do you have an idea which one might stand out?
Yes.
Which one do you think?
I think 37.
Why do you think 37?
Because everything else except for 13 is jumping by 2.
Okay, so 3 to 5, 5 to 7, and then 8 to 10?
Yeah.
Okay, so you think 37 is the outlier?
Yeah.
Only because it doesn't skip by 2?
Well, there's other things that don't skip by 2, so that's not exactly...
Okay, so do you have another reason why 37 might be?
Nope, not really.
What about 8? Could 8 be an outlier in there? Because I say it's the only one that's written up there twice.
It's possible.
So they've got other ones up there. So you want, so if you initially said 37, you feel pretty good about that.
Yeah.
So other than it skips by 1 or 2 or 3 or whatever, can you think of any other reason why 37 might be the outlier?
I don't remember if it's a prime number or not.
Okay, well that's a good thing to think about if it is a prime number because, well, 5 and 7 are prime numbers also, right? And 3, so you've got a couple of different prime numbers. 13 is measured, a lot of prime numbers up there. So think about what numbers are up there, 3 to 37. So we go 3, 5, 7, 8, 10, 13. Those numbers are all pretty close together, aren't they?
Yeah.
37 seems to be quite a bit further out than the other ones.
Like
Does
if we
that
talk
make
about
sense
this
to you?
on like a number line, for example, and you put all of those numbers on a number line, one of them seems to be much further out from the rest of the group, right?
Yeah.
So that would be the outlier.
Yeah.
Okay, so you want to go with 37?
Yes.
All right, well, let's take a look and see if indeed you are correct. All right, 37 is it. So you got the first one right. First problem done. Wasn't that hard, was it?
Nope.
All right. 636-4357 is the phone number. We do have phone tutors available Tuesdays and Wednesdays. And now, time for today's Math in the News. All right, today's Math in the News. This is a pretty hot topic, and this has been on a lot of different social media platforms. Have you discussed at all about saving for your future, or budgeting money, or saving for something right now?
Yes, I have.
Okay, is there something that you're saving for now, or looking forward to in the future?
What I'm looking forward to is saving a lot of money, becoming a doctor, getting more money, and then getting multiple beach houses all around the world.
Well, there you go. You've got a goal, all right? So you're
Okay.
going to have to start saving money. Have you ever heard about budgeting?
Yes.
So when you start getting money, how to budget that money?
You don't use it, or you use it sparingly.
Okay, use it sparingly, all right? So there's something called loud budgeting, all right? So we're going to look at this right now, all right? So budgeting allows you to manage your money and allocate it, put it in different places, all right? So the 50-30-20 rule is a simple way to budget your money, all right? So you have 100% of your money. Say you have $100,
Yeah.
okay? So 50% of it is going to be for your needs. So out of the $100, you're going to put 50% of it, $50, towards your needs. So what are things that you need?
Well,
So pretend you're older or whatever, and you're working. What are things that you would need to pay for?
you would need to pay for your water bill. You would need to pay for food, your gas bill.
Yeah, wherever you're living, stuff like that, right?
Yeah.
So that would be a need, right? 30% for your wants. So what would be the difference between a need and a want?
A need is something that you must need, something that you need to have. For example, you need to have liquids to survive,
Okay.
right? You need something to drink to survive. But something that you want is to drink soda.
There you go. I was just thinking the same thing, soda, right? Because you need water, but you want soda, right?
Yeah.
So you need to have water in your life. If you do not have water, you do not have life,
Yeah.
okay? And then 20% for savings. So if you wanted to save for something else, right? So you would take $20 out of that 100 and put it towards savings for a trip or some particular item that you might be saving for. Does all that make sense?
Yes.
All right, so let's take a look at the next slide. So loud budgeting is the same thing, but you're making it known. You're not doing it like that, but I saw you come like that. Well, everybody did in the studio, I think, right there. But anyway, so when someone asks you to lunch, you decline because you say you would rather take that money and save it for something else that I need, right, or want even more. Okay, than just going out to lunch, right?
Yeah.
So that is loud budgeting. So here's an example of how this would work, all right? So let's say you make $500 a week, which would be $200 a month. Got me so far?
Yes.
All right. So the needs,
2,000 a month.
I'm sorry?
You said
I would say
200 a month is 2,000.
Oh, 2,000. I said 200?
Yeah.
Oh, right. Add a zero. So you know what
It's a
I'm
different kind
talking
of budgeting where you make money and
So
then you get less.
50%, so out of the $2,000 that you're going to get for the month, you need 50% of it, 1,000, to go towards your needs, right? Where you live, your utilities that you were talking about, water bills, stuff like that, insurance, groceries, because you need to eat, right? So your wants, right? If you want to get Netflix, Spotify, different forms of entertainment, going to a sporting event or something like that, and then going out to eat. So then we can see how this is becoming a lot of money. And then saving is 20%. So you need to put $1,000 towards your needs. You want 30% of it, so $600 out of the 2,000, and 400 towards your savings. So that's what it would look like budgeting. Now, if we're going to loud budget it, because see, right now, you need to put $1,000, but you need 1,180, right?
Yeah.
Okay? I'm showing, and then here, so we've got the 745. So let's take a look at the loud budgeting now. Okay? So you want to save more because you want to go on a trip. Okay? These items are going to stay the same. You still have to pay your rent. You have to pay the utilities. You have to eat. Make sense?
Yeah.
Okay. So your wants, instead of dining at $130 a week, you're taking $100 away from that. You're not going to go out as often, right? People go, hey, let's go out to dinner tonight. And you're like, hey, you know what, I'll stay in tonight and eat something at the house, right?
Yeah.
And you let them know that, and therefore they can help you with your budgeting also, because now they know what you're trying to do, all right? And then you take that money and you can put that towards what you're saving more. So that's loud budgeting, because a lot of times kids are on social media, and maybe not as much in 6th grade, but I know high schoolers are a lot and stuff like that, and probably even junior high kids. And loud budgeting is something that is trending right now. So as you get ready to become a doctor, you're probably going to need to know a little bit more about budgeting and stuff, right?
Yeah.
All right, there you go. So who knows? Maybe you do loud budgeting, maybe you won't. But that was today's Math in the News. 636-4357 is the phone number. We have Ryan, a 6th grade student from Buena Vista, in studio with us right now. And you have been working on some different things in class. And why don't you head over to the board for a moment? And what I'd like you to do is talk a little bit about mean, median, and mode to Devin. Explain to him what mean, median, and mode means. And if you guys can show some examples.
So let's go. We got these 3 measures of statistics that we're starting to discuss here. Which one do you think you'd like to explain first of those 3?
I'll explain mean first.
Let's talk about the mean and see if we can put together some ways of explaining this to somebody who may not be as familiar, and then maybe some examples of what that looks like. So how would you describe the mean?
The mean is the average of multiple numbers.
So when you say average, what does that mean to you?
It means like.
How would you describe average?
The average is kind of like, it's not exactly one value compared to another. It's more of like all the values and like the main thing about it, I guess.
So I guess what we can say is it's a single value that's used to describe kind of the other values or all of the values in a set, right? When we think about a set of data, and I think those are important terms to make sure we connect to, what is data and what is a set? And especially in regards to data, I think there's a lot of anxiety when people think about data. Oh, it means I have to do technology or computing. Like, very simply put, data is any set of information. So when we talk about data as it relates to mean or average, so we're really just talking about a set of values or numbers. And when we talk about the set, we're talking about all of the values that we're identifying. So let's come up with, let's just say like 4 values here. What 4 values could we use just in our sample set?
1,
Okay.
2,
Great.
3, and 4.
Okay, so this is a set of data.
Let's
right
add
there.
some more in there.
Yeah.
Since he just did 4.
Don't just go 5, 6, 7, 8.
Let's
right?
put 6 in there because he's in 6th grade.
Okay.
And there's 3 of us in the studio, so let's put another 3 up there.
This doesn't always have
There
to
we
be
go.
in sequential
Let's go ahead
order.
and
And you
try
know
that
what?
now.
What was our outlier in that problem today? 37? Let's go ahead and throw
Yeah,
37 in there too.
Hey, why
right?
not?
Prime number. So this is a set of data, right? If we were to find the average of this data set, how would we go about processing that?
So first, you would want to add everything up.
So you're going to take the sum of the values, and we're not going to actually work this out right now. Right now, we may come back to that another time, but we just want to talk about how we calculate this. Sum of values. Okay, so we would add all of these up. Is that it? That seems pretty straightforward. All right, nice and easy. Great. Quick. Oh, no, there's not. There's more. Okay.
Okay,
What would be the
so-
next part?
You find the sum of values, and then you count how many values you have. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 values.
Okay.
So we divide the sum of the values by how many values there are.
So the mean is essentially a quotient of the sum of the values in a set and the number of values in that set. And when we calculate that out, that gives us what you would describe as an average,
Yes.
which would describe our mean. Okay. Now let's talk a little bit about those other 2. We have the median, and we have the mode. Which should we go into at this time? How would you like to describe one of those others?
Okay, so mode.
Let's talk about the mode. How would we describe what the mode of a data set is?
So for me, I think the mode is the easiest one out of the three. It's just basically the numbers that show up the most.
So the values or the data that appears the most frequent in a set. We want to make sure we can describe this a couple of different ways, just because we know that sometimes describing it one way may not work, but going further in depth. But the way that you described it, it's the value that appears the most in a set. Now, if we kept the same data set, let me just kind of tidy up this 4 here so it's a little clearer. If we have this existing data set, what would be the mode in this instance?
The mode would be 3.
Okay. And you're circling the 3s. Now, what's interesting here is that this data set is not in numerical order of increasing or decreasing value, but you were able to identify that 3 appears the most. I know sometimes to help with organizing a data set, some people will rearrange the order of the values in a set so that it's easier to work with. Is that something you have to do? Not necessarily.
No.
But if you move the data around, does it change the set? No. Okay, so 3 is the mode here because it's the data that appears the most frequent in this set. Let's talk a little bit about the median. So how would we describe the median of a set?
The median of the set is the middle of that set. So for example, if we have 3, 8, 7, 18, and give me a number.
Let's go with 18.
Okay.
How about a second 18, just to throw things off a loop? Okay.
So if we have 3, 8, 7, 8, and 2 18s, then we need to find out the middle. So for the median, it's not exactly essential to move the data around, but it makes it much simpler.
It actually is going to be important to make sure that the numbers are ordered in numerical order because of its placement in the center. We want to keep the same values in that data set. So when we're working on the median, it is important that we are able to arrange in numerical order. And here there doesn't appear to be too much work we would need to do on that. We would, I think, just have to switch 7 and 8 so that they're in increasing order. So if we do that, if we have 3 and then 7 and then 8 and then 18 and 18, our data is organized so that we can find the median. So in these other two, it's not essential that we organize and sort the data, but in median, that does need to be a part of it. In this instance, then, what would the median be?
Well, if you find the middle, the median after you cross everything out would be 8.
So that is the center, the middle of that data collected. And you had a strategy where you kind of eliminated equal parts on the side until you got to one in particular. I'm going to undo a little bit of this work here. And
we're going to stop you guys right
Oh.
there because there's more things we can talk about, but those are the
That's right.
basics of mean, median, mode right there. And for some excellent explanations so far, you've got yourself a pass to any sporting event at CSUB, so congratulations on that. And thank you to CSUB Athletics. And speaking of mean, median, mode, let's talk a little more about it.
Hi, my name is Anjali. Today we're going to be learning about mean, median, mode, and range. So first we have the mean. The mean is the average of all the numbers in the data set. So if we use the data set 3, 6, and 18, we would first add up all the numbers. So 3 plus 6 plus 18 equals 27. Then, since there are 3 numbers, in the data set, we would divide 27 by 3. So 27 divided by 3 equals 9. So 9 would be the mean in this data set. Next, we are going to talk about median. Median is the middle number of the data set. It depends if the data set has an odd number amount of numbers or an even number amount. So if we use the data set 3, 6, and 18 again, the middle number would be 6. But if we use the data set 3, 6, 18, and 29, we would have to add 6 and 18 together, which is 24, and then we would have to divide it by 2 since there are 2 numbers in the middle, which would equal 12. Mode is where whichever number is seen the most in a data set. Sometimes there could be no mode, or sometimes there can be one or even more than one. So if we use the data set 3, 6, and 18 again, there would be no mode because none of the numbers repeat in the data set. But if we use 3, 6, 6, and 18, 6 would be the mode because it repeats twice. But if we do 3, 6, 6, 18, and 18, then there would be 2 modes in this case, which would be 6 and 18. So range is where the greatest number in the data set minus the least number in the data set. So if we use 3, 6, and 18, then we would do 18 minus 3, which would be 15. So now that we talked about all these, we're going to do an example. Okay, so this is the data set we're going to be using. We're going to use 43, 46, 47, 47, 51, 54, and 59. So we're going to add all of them first to find the mean. So if we add all the numbers up, we would get 347. So if we count the numbers in the data set, there is 1, 2, 3, 4, 5, 6, 7. So we would have to divide 347 by 7 to find the mean. So we would get 49.57. In some situations, you would round to the hundreds, but it doesn't matter. You just have to look at the worksheet that you're going to be working on. So the mean would be 49.57. So the median is the middle number, so we would have to count which number is the middle. Since we know that there's going to be 7 numbers in the data set, we have to find the 4th number. So 1, 2, 3, 4. The median would be 47. And then we're going to find the mode. In this, we have to find which number is repeated twice or more than once. In this situation, since 47 is the only one that is seen twice in the data set, 47 would be the mode. The range is where we subtract the greatest number minus the least greatest number, which would be 59 minus 43, which would equal 16. So that's all of mean, median, mode, and range. Thank you.
Well, it was pretty nice. The theme of the day seems to be mean, median, and mode right there. We've got Ryan, a 6th grade student from Buena Vista Elementary. Looking forward to different classes and an elective next year in Warren, right?
Yeah.
Is there anything you think you'll miss from Buena Vista? Because you've been there for 7 years.
Well, I might miss my friends because I think more than one are going to be moving to different schools than.
Oh, okay, that's a good
Warren.
point, because not all of you will automatically go to the same school. Some might be
Yeah.
moving or something like that and going to some different schools. But you're going to be making a lot of new friends also.
Yeah.
All right, good. Well, I'm glad you're looking forward to that. So you were working on mean, median, and mode, and you gave Devin an explanation, and you guys talked about those 3 things, right?
Yeah.
All right, so head on over to the board. I've got a beautiful problem for you right here.
Beautiful.
This is lovely. So you have to find 5 numbers where when you calculate them, the mode is less than the mean and the mean is less than the median. So discuss with Devin, how are you thinking? What do you think you want to start off with? How do you want to attack this and discuss it. And I'll give you guys about 5 minutes and go ahead and start on it.
5. We can do 5, right? We can
Yeah.
do 5, Ryan. All right, so how should we start off with attacking this challenge here, where we need to come up with the data set where the mode is less than the median and the mean, I'm sorry, mode is less than mean and mean is less than median.
Can we do 1, 2, 3, 4, and 5?
We can start off with 1, 2, 3, 4, 5 and see what we end up with and kind of work from there. So let's go ahead and write this down. 1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
All right, now we have our data set. Let's talk about which of these we can find right away.
Well, what we can find right away is the median.
Okay, and we've put them already in order. So what is our median?
Well, we don't really need to do this part. It's pretty obvious. But
It's going to be 3. So I would appreciate the visual for our viewers watching from home. So the median here is going to be 3. I'm going to go ahead and clear that out, bring that back. So we know our median is 3. We need a mean less than 3 and a mode less than that. I feel like we're going to run into a problem with the mode, though. What do you think might be the issue here with the mode?
Well, I have a question.
Okay,
So, can a mode be none?
so this brings up a really interesting situation. In our data set, every single value is unique. There are no instances where a point of data is repeated. In this instance, we don't have a mode. And if we don't have a mode, can it be less than a mean or a median?
Oh, no.
So in order for that mode to be less than, it needs to exist so that we can know for certain. So in this instance, 1, 2, 3, 4, 5, before we even try to calculate the mean, may not work. We need to have a mode, and it needs to be the lowest of the 3 values. So let's revisit this data set and come up with a way to either change it or come up with new values that would give us a mode that would have a fairly low value.
Well, if we change, wait, can we change it so then there's 2 of the same numbers? Or it
We
must
can do
be-
whatever we want. We just have to find out if it's going to work after we do it. So what could we change here?
We could change 2,
All right, we're getting rid of 2.
change it to 1.
All right, so we have a mode now. What's that mode?
The mode is 1.
Great. Now, let's talk about the median. Does the median change in this new data set?
No.
No. Because if you eliminate the sides one by one, we still end up with 3 at the center of this data. So we now are at the point where we have a mode of 1, a median of 3. If we can find a mean that resides between those 2, then we'll be on point. So let's talk a little bit about this. How do we find the mean of these values?
We need to add them all. Wait.
All right.
Yeah, we need to add them all up.
So let's go ahead and add those up there.
So 1 plus 1, that's going to be 2. Then add the 3. That would be 5.
And I know we have a 5 over here, so that's going to be 15. I'm sorry, 10 plus that 4,
That'd
and that's going to be
14.
14. Now, what do we do with that 14?
Now we divide it by how many, the data in the data
So
set.
how many values there are in the set?
Yeah.
So how many values do we have in this data set? And you'll see a data set usually signified with that bracket off to the side, or parentheses, or some sort of grouping symbol to enclose that data set. So how many points of data do we have in this set?
If you count them all, we have 1, 2, 3, 4, and 5.
So that means we're going to be dividing 14 by 5. Now, before we actually work this out and process this through, my question to you is, can we use reasoning to figure out if this is more than 1 and less than 3? So here's what I mean. 14/5, is this greater than 1?
Yes.
How do we know?
Because 5 5 goes into 14 multiple times.
So the numerator is greater than the denominator, right?
Yeah.
Okay, in that instance, we know this is greater than 1. Do we know that 14/5 is less than 3?
Yes, because if 15 is over 5, that would already equal 3. So 14 over 5 would be less.
So because you know that 15/5 would be 3, and we have a lower denominator, a lower numerator, then this has to be less than 3. So 14/5 as the mean is greater than the mode of 1 and less than the median of 3.
So I think you guys have accomplished it. You found 5 numbers that satisfies the mode less than the mean, less than the median. So your numbers are 1, 1, 3, 4, 5. So nicely done.
And what was interesting about that too is that all you had to do was change one value in your data set that got you to a mode that you could start off with, and it ended up being a value that lowered the mean. Because if you would have left this at 2, the mean would have ended up 1 more than 14, 15, and it would have been 3.
There you go. All right. Well, we know that Ryan has been thinking about having many beach houses all around the world with him being a doctor. But right now we're going to take a look at a different career pathway.
What's so exciting about it is them really understanding that, yes, I can do this. It's not that I can, I am doing this.
How do you think your ad is going to attract customers? Let's put it down there and let's make it come alive, and you see opportunity. So we teach that where other people see problems, entrepreneurs see opportunity.
How to start it, how to run it. I was like one step ahead. It started growing pretty quick thanks to social media. More known, more followers, and more orders all over the country, and even to Canada, Australia, shipped overseas. It's really hard to keep up. Right now, it takes about a week or 2 to ship out a hat. The customers understand. They understand that I'm not a huge company right now, just a small business. This past month, we did about 800 orders. That's combined though, both in-store and online. If I get enough help, I want to start up a second store, more in the city. My senior year, high school, went to the ROC Entrepreneurship small business program. That kind of influenced me to start a business. Mr. Russo's class helped me a lot.
Try to tie your sales to a special event. So this is a bath bomb store, so Mother's Day is the perfect opportunity to run with that. So I think that was well conceived. We teach the entrepreneurial mindset, and entrepreneurs are perpetually optimistic, okay? You always know that failure is a possibility, but you push forward despite that.
So what we're doing is figuring out more ways for students to engage in actual action-based activity and experience as part of entrepreneurship. The more that we can be experiential and we give them this experience and they put this in action, that reinforces the learning, it reinforces the confidence, and we find that they continue to go forth in these endeavors.
My first thing I sold was earrings. I make them, myself. I sell things on Instagram. I tried OfferUp, but no, it didn't work.
What worked today? What didn't work? What can I do? We teach pivoting and how can I move in a different direction for my business? Who is my true customer and what are their needs?
I've sold a lot. I've sold 3 big boxes of 50. Yeah, I know a lot of kids like hot Cheetos, and then cheese is a good combination.
My business, I sell crochet items and drinks, and I think it's going pretty well. I sold out of the sodas so far, so I only have very few drinks. Kate, she was selling hot Cheetos and chips, and when she sold out of chips, we sold her our chips, and then she would sell them and give back what we sold her for it.
One of our objectives here at the ROC campus is to get our students prepared for post-secondary education. So what a better way to have them go through an entry-level course in their pathway.
But it's taught by me in this classroom, and we work them through the entire curriculum. I use the exact same curriculum that BC uses. The students are able to get 3 business units that go on their transcripts, and those are transferable, so they can take those to any college.
Out in the real world, you hear a lot of no's. It's always no, no, no. And you know, entrepreneurship is all about embracing that no and overcoming rejection. It's the mindset of being able to be who you want and do what you want.
All right, in studio we have Ryan, a 6th grade student from Buena Vista Elementary. And I like how you guys reasoned your way through that final part of that problem, where you knew the answer was greater than 1 but less than 3. So you don't even need to figure out what that decimal would be. But you know it's in between there, right?
Yes.
Yeah,
So
well,
that's a big part of mathematics, is reasoning your way through those things, right? And you knew the mode had to be a low number, right? So you didn't want to make it 5, right? Because then you would have to have numbers larger than those, which would have been hard with that set you already started off with. So you ready to try one more of those?
Yes.
Yeah, there
Extended
you go.
pause,
All
but we
that's
can
what I
work
like
with
to
that.
hear.
A little bit of
Hesitating.
breathing. Yeah.
Yes. All right, good. All right, head on over to the board. So, Ryan, would you like to start with the mode as the lowest, the mean as the lowest, or the median as the lowest?
Can I do the median as the lowest?
By all means. So we'll go median
By all median.
is less than the mean, is less than the mode. So once again, you must have 5 numbers that satisfy that.
Now, just on observation here, what do you notice about the order of this compared to the last problem that we faced?
I think everything was switched.
Right, that's what I noticed too. Last time the mode had to be the lowest with the mean in the center and the median as the highest. So how might that inform the values you start off with based on that prior experience?
Do I just like need to flip it?
We could, let's see what happens, right? Like that's the thing about, I think, a lot of these challenges. A lot of students get so stuck up on like, I don't know what to do. When we don't know what to do anything, do something, and then see what happens. So based off of how we did that last problem and what you're seeing about the structure of this, let's do the flip of that. So when you say the flip, or how do you want to lay this out, or what type of values do you want to use for our data set?
Well, I would like to use the same numbers, but negative.
Whoa, okay, so we're flipping to the other side of 0 here. We're working into the negative zone. So you want to use then -1, -2, -3. Now, when we order those, it's to our benefit to organize those from least to greatest, right?
Yeah.
So which would be the least in that group?
-5.
-5. So let's do that. Let's start off with -5, -4, -3. We didn't have -2 in our last set.
Nope.
So do we want to have 2 -1s here?
Sure.
Okay. And 2 -1s. I think there are some viewers at home like, how are you going to do the average of negative values? How is that possible? We're going to find out how that's possible. So which of these can we identify most quickly?
The mode.
Okay, what's our mode?
-1.
-1. It shows up twice. It's the most frequent of our data set. We're going to put it here. And we're going to check to make sure afterwards that it fits into the sequence of less than, less than, less than. What's the next one we can identify fairly quickly?
We can figure out the median.
Okay, what's our median?
The median is -3.
-3. Now, I saw you were kind of checking to make sure that they are in the right order from least to greatest. Again, because these are all negative values, we're going to start off with our -5 here, since it has the greatest absolute value, the distance from 0. It's going to be our least value. So here, -3 would be our median. Right now, let's just check in here. Is -3 less than -1?
Yes.
Yeah. If we put these on a number line, -3 is going to be further to the left of -1. So that checks out. Now we've got to see if the mean of these 5 negative values falls between -3 and -1. Now, when we added the positive versions of these, what was their sum?
The sum was 14/5.
So, if we just look at, so we know we have 5 values. We're still going to be dividing that sum of these values by 5. What is the sum of all these negative values?
-14.
Maybe -14, absolutely. And you can do this through a bunch of different proofs. You can start making jumps on a number line and work further into negative territory. But this is all going to add up to -14. So let's again use our reasoning here. -14/5. Is this greater than -3?
Yes.
Explain.
Because -14 is,
And remember, it's not -14, it's -14/5, right?
oh. So if you have -15/5, that would be -3. And if you, since this is like one number lower, then it's just going to be less.
So if we're thinking about this on a number line, this might be -14/5 over here compared to -3?
Yes.
Okay. Is -14/5 less than -1?
Yes.
Okay, explain.
Because if you're on the other side of 0, when it's positive, this would actually be more than -1. But since it's negative, the more is actually less.
So what you're saying is, on this number line, let's say 14/5 is here, positive 14/5. Compared to 1, it's greater. When we flip this and we work negative, -14/5 is going to be less than -1 when we mirror that. So whatever might be true when these values are both positive, the opposite is going to be true when they're both negative.
Yes.
So we have a median of -3, a mean of -14/5, and a mode of -1. Do these values fall under that sequence of less than?
Yes.
Okay. I think that you came up with a really efficient way of coming up with a set that you could use based on your logic and reasoning from the previous set that you did, where these were reversed. And you applied that thinking to come up with an efficient solution right off the bat.
And that's an important step to take, because a lot of students would think, all right, well, I need to use positive whole numbers, right? But there's nothing that says the numbers can be not, they can be negative, they could be mixed numbers, there are all sorts of things they could be. They could be decimals. But I like the way you approached it, is like, all right, well, if it worked one way and all I did was switch to the last 2 measurements, all I have to do is reverse the numbers.
When he said
and by
flip,
going in the reverse order,
yeah.
that's all you had to do.
When you said flip, I thought you were just going to put the numbers in reverse order, and we'd end up right back where we started.
I don't think that would be helpful.
Well, it may be helping to draw out the time on the show here, but
Well,
we got to what we needed to, and you showed
nicely
up.
done,
Showed up
though.
big.
All right, 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now to find out what's going on this week at NASA.
A commercial lander touches down on the moon, discussing the science on the space station, and preparing for the next space station crew rotation mission. A few of the stories to tell you about this week at NASA. On February 22nd, Intuitive Machines' Odysseus lunar lander touched down near the south pole of the moon, marking the first lunar landing as part of NASA's CLIPS initiative and Artemis campaign. Intuitive Machines is one of several U.S. companies NASA is working with to deliver science experiments and technology demonstrations to the lunar surface, to help the agency explore the moon in advance of Artemis astronaut missions to the lunar surface, and ultimately crewed missions to Mars. During an Earth-to-Space call on February 21st, NASA leadership talked to the crew aboard the International Space Station about scientific research and technology demonstrations taking place on the orbiting laboratory. This included research that could improve our understanding of what leads to age-related bone loss in humans, and a small robot that can be remotely controlled from Earth to perform surgical procedures in space. Learn more about science on the space station at nasa.gov/station. The members of our upcoming SpaceX Crew 8 mission to the International Space Station entered quarantine recently, one of the last major milestones before heading to Florida for final pre-launch activities. The crew, including NASA astronauts Matthew Dominic, Michael Barrett, and Jeanette Epps, will perform research, technology demonstrations, and maintenance during their stay aboard the space station. Launch is currently targeted for no earlier than March 1st from our Kennedy Space Center. All the major structures that will form the core stage of the Space Launch System, or SLS rocket for our Artemis 3 mission, are structurally complete. Technicians at our Michoud assembly facility recently finished welding the 51-foot liquid oxygen tank structure. The mega rocket's other giant propellant tank, the liquid hydrogen tank, is also a fully welded structure. Both tanks will be a part of the rocket used for the first of the Artemis missions, planning to land astronauts on the moon's surface near the lunar South Pole. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always interesting things going on at NASA, especially with what's happening this week, right?
Yeah.
Landed, went over.
They forgot that
and
part,
so-
tipped over on its side, but it's still processing some data and sending it back. Just a little bit of a delay, but still, it got there. Who am I going to
A little grainy and stuff also. But anyway, we'll
That's the moon for you.
discuss that more. Anyway, we've got Ryan in studio doing some excellent work with mean, median, and mode. But we're going to shift gears now, all right? So you and Devin are going to work on ratio and surface area, all right? So head on over to the board. You guys have got about 5 minutes to work on this.
There's a lot going on here. So go ahead and read out this problem for us.
The ratio length, width, height of a box is 3, 1, and 2. If the height of the box is 10 centimeters, how many square centimeters is the surface area of the box?
Oof, there's a lot here to get through. So we have a few elements to take note of. First of all, we have a triple ratio. How often have you dealt with a triple ratio? It's okay to say never. It might be never. I'm just looking at your expression.
Yeah,
It's
I don't
never.
think
Okay, I'll put it to you this way. If we have a ratio of 2 to 3, let's come up with an equivalent ratio. We could
4
say
to 6.
4 to 6, great. Okay, same concept. Let's say this ratio was 2 to 3 to 5.
4 to 6 to 10.
A ratio doesn't necessarily just have to be two values comparatively. It can be more than that. It's still represented with the colons. Now, we are talking about the length, width, and height ratio of a box. If you need me to draw a three-dimensional model for this, I'm more than happy to do so. How confident are you in your ability to draw three-dimensional models? We're going to find out, I guess, huh? How would you draw a box for modeling something like this? Or a cube, or any type of rectangular prism?
So I'm going to go down,
Okay.
over, up.
Okay, we have our front face. There we go. Great. Okay. Well done. Once we get to this point, we can feel pretty confident that we are going to at least get to a helpful model. Because what we just really want to show...
Wait, oh, no, it's going
Oh,
that
we're
way.
fine. We're fine. We're fine. We can finish that out just, with that behind the scenes of those pieces here. But the idea is the same, right? Like we have our length, we have our width, and then we have our depth, or however they want to express it. Maybe we change this up. Maybe this is going to be our height. And then we have our length here, and then we have our width this way. Now, if this is a box that has a length to width to height ratio of, let's say, 3 to 1, and then to 2, just to make a model similar to how you designed and laid yours out. We know that we have a box here where the height is going to be 10. If that's the case, what would be the length and the width of this box?
So if the height is 10, wait, is this matched up with this?
Let's see. Length is 3, width is 1, and height is 2. And then the height of this box is 10.
Okay.
Good check, though, to make sure that all of our dimensions are organized accurately, because as you're aware, the order of those ratios matters.
So if we're just gonna try and find the width, then I would think that we would try to find what the height is, because 10 is the height.
Well, we know the height is 10, right?
And since this is a 3:1:2 ratio, I'm going to divide 10 by 2. So then 1 would be 5.
So essentially, you found that the comparative ratio of the original and the box, so it's 5. You have a factor of 5 here, okay?
So the width would be 5.
Okay.
And then 5 times 3, that'd be 15. So I think this bottom
All
is
right.
15 centimeters.
Now, let's take a look at what it's asking us to find. How
You guys
many
got about 2 minutes.
square centimeters is the surface area of the box? So, surface area, a little different than volume, right?
Yeah.
We're essentially looking at the area of the surface of this cube. It's not really a cube, it's a rectangular prism, but what do we know about rectangular prisms that might help us do this quicker?
Length times width. Wait, no.
Well, that would be volume, right? But you caught yourself. We know that opposite sides of this rectangular prism are going to have the same areas, right? So, for example, the front of this is going to have an area of 15 times 10, 150, right? Because that's the length times the height. I know that the back of that is also going to be 152. I see that you're keeping that brain from exploding from your mind right now. So what can we do with this?
So if this is the length going this way, and this is the width, imagine that's going back, then this bottom piece would just be the height.
So,
I mean, this.
okay, so you're talking about the top and the bottom are going to have the same area too. This would be 15 times 5.
100 and no. 5.
Well, we can count by 15s 5 times, right? We can go, oh, you got this. You're processing. You're pushing through. 75. Now, 2 of those because we have the top and bottom, right? So I'm going to take the front and back here. That's 150 times 2. That's 300. You have 2 of your top and bottom here. 75 times 2? Or just double 75?
150.
150. Now, we've got our top and bottom. We've got our front to back. What about our sides here? How do we find the surface area of one side?
Of this side?
It'd be like this side could be an example here, right?
Would that be width times height?
It'd be width times height. So this was 5 times 10.
50.
And we have 2 of those, so double 50.
100.
So we have 300 plus 150 plus 100 for our square centimeters?
Yeah.
Okay, so let's add those together.
So these 2 would be 250.
All right.
Plus 300, that would be 750.
300 plus 250 is 750?
Wait.
There you go, 550.
550.
550 square centimeters.
Nicely done. Well, you know what? While you guys were working on that, we had Malachi from Cato calling with an excellent problem. We're not able to get to it right now, but I know that Mickey, one of the phone tutors, helped him out with that. And for calling in today, you're going to get yourself a meal courtesy of our friends at Grill and Burger. So congratulations on that. Hey, you know what? It's March Beats going on right now. And our very own hot rod expert's going to tell us about one of the tools that he uses.
I'm John, and we're back in the Do the Math Hot Rod Garage talking about the tools of mathematics. Our dragster and drag racing is nothing but mathematics. Everything on our car is a measurement, is a calculation. Let me show you one of the tools that we use on a regular basis. To keep our car running properly and to keep it tuned up, We've got to make a lot of measurements, and some of those are pretty precise. Let me show you one of them that can be a challenge. This is a spark plug that we're going to run in our Hemi. One of the critical measurements is this little gap in between the electrode and the ground strap. It's the gap in between the center electrode and the grounding strap that a spark of electricity will jump across when the engine fires. That spark of electricity is going to ignite the fuel-air mixture in each cylinder and make our Hemi run. That's what's going to make the power, is that spark. That distance between the center electrode and that ground strap is critical to our engine running properly. The manufacturer wants us to have an 18,000ths of an inch gap right there. Let's try and measure that gap. If we take a conventional tape measure, well, that's not going to work very well. Our tape measure doesn't hardly fit in there, and it's not graduated to thousandths of an inch. No way am I going to get an accurate reading on that. I can try dial calipers. That's another tool of measurement. It's graduated to the thousandths of an inch, but I have a hard time getting the end of my calipers in to the gap. That's not going to work either. We've got a very elegant and simple solution to our problem. It's today's tool of mathematics. It's called a feeler gauge. All a feeler gauge is a series of pieces of metal that are ground to an exact thickness. The thickness in thousandths is engraved right on the piece. So I'm assuming that this is going to be about 24 or 26 thousandths. Let me go and find the 26 thousandths blade. Put my glasses on so I can see a little bit better. It's bright out here at the hot rod garage. Here's 26 thousandths. Let's see if that's the gap of the plug as we received it. Oh, it is. This 26 thousandths feeler gauge just makes it in between the electrode and the ground strap. That's telling me that that gap is 26 thousandths. That's never going to work for a race car. We've got to reduce that gap. We've got a tool to do that. We can take the spark plug and place it in this tool. This tool will let us take and bend our ground strap closer to the center electrode. We're not just going to guess on that. We're going to take our feeler gauge, set it to 18 thousandths of an inch. Got to go and find the 18 thousandths. There's 18 thousandths. I'm going to set that right inside our gap so we know when this is bent, it's 18 thousandths. Squeeze it down to bend that gap. We're bending that electrode down now. Take it out. Perfect fit. We've now gapped this spark plug to 18 thousandths of an inch using a simple tool of mathematics, the feeler gauge.
Nice to see John right there, our resident hot rodder, and he is at March Meets this week, and a little bit about the feeler gauge. So, Ryan, did you learn a little something today?
Yes.
Good, I'm glad you did. Did you have fun today?
Yes.
Good, I'm glad you had fun as well. So hopefully if you have some more questions about that mean, median, mode, you can give us a call at Do the Math. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.